Okay, today we're going to be talking about monomial factoring, cancellation, and then parallel lines. So if you recall, a factor is one of the numbers or expressions in a multiplication equation that we're multiplying together to get our final product. We've also looked at the distributive property. So here are some examples of factors. 5 times 2, those are both factors of 10. 5 times 2 is 10. 5 times 3 times 4 is 60. So these are all three factors that give us a product of 60. Also think about this. If I was to do, kind of going back to the distributive property, if I was to do 5 times 4 plus 3, if you recall, we distribute the 5 out to the 4, and we distribute the 5 out to the 3. So this would be 5 times 4 is 20, plus 15 is 35. But if I had 20 plus 15, I could actually go backwards by saying, what is the greatest common factor of 20 and 15? Which is 5. Okay, you've learned about the greatest common factor before. The greatest common factor of these two numbers is 5. So I could actually factor out that 5 and go backwards to this original equation that I have up here. I could say 20 is the same actually as 5 times 4. 15 is the same thing as 5 times 3. Now that I've got my greatest common factor out here, I can translate that back into what I had here. I can say this is actually the same as 5 times 4 plus 3. And so that's what we're going to be doing today. We're going to be kind of reversing the distributive properties, kind of how you could think of it. So right here, we're going to try to factor this expression. What is the greatest common factor of 5a times b squared plus 5abx? We can see they both have a 5, so our greatest common factor is going to include a 5. They both have 1a. They both have at least 1b. Now, if this was b squared, we could say b squared is part of the greatest common factor, but this actually only has 1b, so the greatest common factor is going to be just a b. Now there's no x in this first term, so we can't put an x in our greatest common factor. And in fact, this is our greatest common factor, 5 times a times b. Now we take 5 times a times b out of each term, and we write the result inside the parentheses. So if we take all those away from here, we'd only be left with a b. If we take it all away from here, I can just kind of box it off here because it's written out exactly. We're just left with an x. And so here's how you factor this expression, 5 times a times b times opening parentheses b plus x closing parentheses. And again, if you distributed this back out into kind of an expanded form, 5ab times b plus 5ab times x, you'd end up back at your original expression. So let's practice factoring these two expressions here. We can see that both of these numbers have a 5 in them. If you think about writing these out as complete factors, and it might be easier just to go ahead and do this if you're struggling, write this out in prime factors. So 5 is a prime number, times m, times m, times x, times y. And you can put parentheses around here if you want to, just to make it clear, minus 2 times 5, those are the prime factors of 10, times y, times 3x's, because I have x cubed, and then times m. So now I can see for each of these numbers which one appears in both sets, and I need the least amount in this case that appears in both sets. So I don't have a 2 in both sets, so I'm going to ignore that, but I do have a 5 in both sets, so my greatest common factor is going to have a 5 in it. I also have some m's over here, and I have one m over here. So the least number of m's that appears is 1. So I'm going to have 1m. I have 2 x's here and 3 here, so I'm going to use the least number, which is 2 x's. And then I have a y here and 2 y's here. So 1 y is my least number of y's. So this is my greatest common factor. Of course, I would write this as x squared. And now what I'm going to do is I'm going to take this greatest common factor out of each of these two terms, and whatever I'm left with is what will go inside the parentheses. So I'm actually going to use little cancellation. I'm going to kind of cross them out just to make it easier visually to see. So I'm going to take the 5 out. I'm going to take 1m out. I'm going to take out 2 x's. I might have to cross those out like this or something. Okay, and then I'm going to take out a y. So what am I left with? Everything is crossed out except for an m. So I just have a single m here, and then I have my minus symbol. Now I'm going to do the same thing. I'm going to take out a 5. I'm going to take out an m. I'm going to take out 2 x's, and I'm going to take out a single y. So I'm left with 2, a y, and an x. I'm going to write them in alphabetical order with the constant first. So that's going to be 2, x, y, closing parentheses. So here's my final expression, except that I would change this into x squared. So let's rewrite this one more time. 5mx squared y, opening parentheses, m minus 2xy, closing parentheses. Let's do it one more time. 6xy squared minus 2xy plus 8x squared y. So what is my greatest common factor as far as the constants? It's going to be the number 2. These are all even numbers, so 2 goes into all three of them. So it's going to be a 2. What about x's? What is the least number of x's that I have between the three terms? It looks like they all have at least one x. So I'm going to put an x here. What is the least number of y's that each of the three terms has? It looks like it's going to be 1. So there's my greatest common factor. Now I'm going to take 2xy out of each of these terms. So 6 divided by 2 is 3. I take out the x, and I have 1y left over, minus 2 divided by 2 is 1, so I won't write any constant here. And then I've got an x and a y here. You can see that 2xy is the same as my greatest common factor. So this is actually just going to be the number 1. So minus 1. Think about it like this. 2xy times 1 is 2xy. 2xy times 3y is 6xy squared. So I'm still going to have a 1 there, not a 0. Plus, if I take 8 divided by 2 is going to be 4. X squared divided by x is just going to leave me with 1x, and then a y divided by y is going to give me 1. So there are not going to be any y's here. And to double check your work, of course, you can always distribute this 2xy back out to each term and make sure you end up with the original expression. Okay, let's transition to cancellation. So we say that multiplication and division are inverse operations, meaning that they undo each other. So for example, if we had 5, we multiplied it by 3, and then we divided by 5, the two 5's cancel each other out to become 1 over 1. And what we're really doing is multiplying 3 by 1, so we end up with just the 3 left. Really, you could think about it the reverse way, since with the commutative law, you can multiply these two factors in any order. You can think about it like this. 3 times 5 is 15. Divided by 5 is going to get me back to my original 3. So the division here undoes the multiplication. So when we have a number that is a factor on top of a fraction, the numerator, and we have that same number as a factor in the bottom of the fraction, think about it like this. This is going to be this number times 1. We can actually just cancel these out, because what we're really doing is we're multiplying this number here by this number and then dividing by the same number. So these undo each other. We can cancel them out. Our final answer is simply 4.2. Same here. We've got a factor of 3 times whatever's in parentheses divided by 3. So we're multiplying by 3 and then dividing by 3. So these cancel out, and we're left with just x plus 4. Now in this case, you can't cancel the 2 and the 2 because the 2 up on top is not a factor of a multiplication problem, right? So we're actually adding, these are add-ins, we're adding these two numbers together, so you can't cross out these two. This is actually as simple as this expression can get. This one is a little different because we can actually use what we just learned, the factoring we just learned. We can actually pull a 5 out of both of these terms and say that the top is 5 times x plus 1. So you can see we factored out the greatest common factor here. What we did on the previous slides, we took the 5 out. This is now 5 times x plus 1 over 5. And now you can see we've got a 5 as a factor and a 5 down here as a factor. We can actually cancel both of those out. They become 1 over 1. And we're left with a simple expression of just x plus 1. Okay, let's finish by talking about parallel lines. So these little arrows here tell us that this line and this line are parallel to each other. And if you have a line that crosses both of the parallel lines, it creates some equal angles. It's called transversal. So this angle here, I'm going to mark it with a 1 dash, and this angle here are going to be the same angle. These two angles are the same because they're what are called vertical angles. Okay, they're kind of across from two intersecting lines. And again, if two of the angles in two different triangles are the same, we know that third angle is also the same. So these triangles, whether they're the same size or not, are similar triangles. And of course, once we find out that triangles are similar, we can use that to determine other things like the corresponding side lengths and things like that. These triangles we've also looked at before, the overlapping triangles. Because these two lines here are parallel, we also have similar angles here. This angle and this angle from this transversal are going to be the same. Same as this, so this is also a transversal that crosses across both of these parallel lines, which means that this angle is also going to be the same as this angle. And of course, this angle is the same in both triangles already. So these are also similar triangles. All right, that's it for today.